Hello and welcome from the product management team. My name is Klaus-Peter Sauer, and together with my colleagues, we are covering the What's New in SAP Datasphere session on features, functions, and enhancements, which we delivered in the last quarter of 2024. Let's have a brief look at the agenda, what we have planned for this session. So first, a few general product updates, then we will dive into updates we delivered in the data integration area, followed by updates and enhancements we delivered in the data modeling area, and then we cover a lot of other various topics like in the spaces area and the administration governance area. And at the end, I will give you an outlook on what to expect in the beginning of 2025 and during the course of the year. So let's have a first look at some general updates, and there I want to highlight a blog series, a very successful one by my colleague Sandy Tran. So she's focusing on the BW area and covers in her two blogs now features and functions you might know from your BW background and how to natively implement these kind of features or functions directly in Datasphere. So there's already a successful blog out there since Q3 of 2024, and now in December she added another blog with also some videos where it is explained in detail how to set it up and achieve certain functionalities. So in this second blog part, she's covering like hierarchy with directory, advanced data store objects with changelog, key figures and exit variables in queries. Very interesting. And it's not only these two blogs covering these kind of topics, but we also had like a tech ed session on October 9th last year, which is available online as well. So let's have a brief look at the blog. So it's located at the SAP community. You find the link in the slide materials, right? And as you see here, it's a combination of text and then links to the individual videos where you get a deep dive and also links to the respective parts of the help documentation. With that, let me hand it over to the next section on the data integration topics to my colleagues Daniel Krämer, Daniel Ingenhaag, and Mostafa Shaarawy. Over to you guys.
The topic that I want to talk about today with this user story is what we call the delta interval live patch in the replication flow. In the end, what it is about, it is basically kind of improving the flexibility for users to adjust the delta load interval in the replication flow, which is per default 1 hour, without actually forcing customers to basically reinitialize the entire replication, because that was kind of a smaller feature out of, let's say, a series of other ones in order to make the usage of the replication flow more flexible and avoid a big impact with now forcing customers to reload all of the data, because that's obviously kind of a big pain point because it costs a lot of time, effort. And if you load then the data via premium output integration, it comes also with an additional price tag. So certain improvements have been already delivered throughout the year, and this is now an additional one where we want to basically offer a better usability for the end users in the end. And with this story, users can basically now change the delta load interval on the replication flow level dynamically. And they just basically need to go in and then change the value and save and redeploy an existing one. And that will basically not result in the situation that you need to reload everything. So they can really adjust it based on different needs, because in the end, requirements can change, that you start with a certain interval and then you want to change it in future for certain reasons. For example, you came to know that in the end the data might not be needed that frequently and you go for a less frequent approach, or the other way around. Another indicator could be, for example, based on the delta volume that need to be replicated in the end. So overall, we just want to provide more flexibility for users to adjust it over time based on changing requirements and changing needs in the end. And that is basically what we want to offer here. We also provided a quick link to the help documentation. In the end, if you have a replication flow, we are basically talking about that setting. And it's like always since the beginning, it's kind of a setting that is relevant for the entire replication flow and for all the replication objects that are in. Of course, it's only relevant for the ones that are having the load type initial and only, of course, because if you have a data set that is not supporting delta, then of course this interval is irrelevant. And it's only relevant for those where you actually also support data loads. I think that's quite obvious. And like I mentioned, if you have now replication flow running, the only thing that you need to go and do here is change the value to another one. For example, I can change it from maybe 2 hours to 5 hours, and then you can just simply save and redeploy it. And important to know, that is what I also put on the slide, is it will basically take effect after the next scheduled iteration. So if you have now an interval of 1 hour and the next one is, for example, coming in 30 minutes, and you change the interval in between, it will still go ahead with the next scheduled time that was done previously. And after the next scheduled one, this new interval will basically be taken into consideration. That's just one important thing that I wanted to mention. And it's also exactly described like that in the documentation as well.
Okay, perfect. So yeah, as you can see in the title, there's a new source connectivity now available for replication flows, and it's Confluent, either Confluent Cloud or Confluent Platform. So both are Kafka offerings. So it's now possible to consume Kafka topics that contain messages which are either of type JSON or have an Afro schema. There are certain possibilities to configure schema settings as well as the load behavior, since we are talking about semi-structured data in general in Kafka. And therefore, of course, if we want to load the data into Datasphere, we have to somehow translate it into a relational schema. So there are certain settings and configurations available, but we will see them in the demo system in a few seconds. There is going to be an automated flattening of nested structures. We will also see this. And maybe let's directly close the presentation and jump into the demo system. Maybe one remark before we jump. The connection type that needs to be used if one wants to consume Confluent Kafka sources is, of course, the Confluent connection type. This is not working with the generic Kafka connection type. It's only the Confluent connection type. Okay, let me just quit this. Go to the demo system. So first, a few words about the setup. So in a Confluent Cloud cluster, I have created a demo topic, which contains a couple of sample messages. On the right side, you can see how the structure of such a message is looking like. The content is not really important. The structure is more important. And as you can see here, it's a nested structure. It contains, so to say, root properties as well as nested properties. And there is also an array, for example, that is contained in the message itself. And if we have a look on the corresponding schema, it's a JSON schema for the sake of simplicity now, but Afro schemas are also working. And if we have a look here, yeah, it looks like this. If we want to use Confluent as a source in replication flows, it's a must-have that each message that needs to be consumed has a schema attached. Without a schema, it's simply not possible to replicate a message. And yeah, for our example, I have only one schema defined. In theory, of course, such a Kafka topic can contain messages which have different schemas attached or comply with different schemas. But yeah, for this example, I think it's sufficient to only look at one specific schema. Okay, let's now switch to SAP Datasphere. And let's jump into the replication flow editor. And let's select our Confluent system. So I've set up the connection. It's the same compared to if one wants to use Confluent as a target for replication flow. So this is my Confluent demo system. And the first thing that I should mention is the selection of a container. So what one can select here is, as a container, is a so-called Confluent context. This is nothing else than a namespace for Confluent schemas. So a context as well as a schema is not directly connected to the topic itself, but we decided to have it as a container artifact on replication flow side, since it helps to determine where to search for a certain schema. And as a source object, we simply add a topic. Of course, this is a large demo system, so we choose our demo topic, click on next, and then simply add selection. And what happens here is the demo topic contains certain messages. Datasphere itself, or the replication engine, searches for the latest message, takes it, extracts the schema ID, searches for the schema ID in the schema registry, and then makes a proposal for the schema that is supposed to be used for this replication task. So if I choose Datasphere, for example, as a target, I get a certain proposal, which schema is supposed to be used. There are two dedicated sessions on the right side that I will explain in 1 minute, but let me first simply save the replication flow, deploy it, and then maybe run it, since this will take 1 minute or so. Okay. We simply save it. And let me deploy it. And hopefully then I can more or less directly execute it, but let me switch to this task. So per task, we select the topic, and then based on the algorithm that I explained, or method, we get a proposal for a certain schema that is selected for this topic. And here we can see where the schema is stored in the schema registry of Confluent. Let me just run it. Let me switch back to the task. So again, here, that's so to say the schema. There's also the version that is specified, that is used. Of course, in our example, there exists only one schema version, but in theory, there could be several versions of the same schema. And there's also a specification whether we want to include a technical key or not. And of course, in a topic, there can be several messages that can have different schemas, and there is the possibility to do a configuration. So if, for example, the schema that was selected based on the latest message that was sent to this Kafka topic is not the right one, I can simply via a drop-down select it. I can also select the schema version if there are several ones. And yeah, on the right side, you can see a flattened version of the source schema. If we switch back to the schema itself, maybe let me go back to the message, then it's easier to understand. From beginning, the messages are older. You can see here we have a nesting. We have a personal section which contains 3 sub-properties. And this is, so to say, flattened here with a dot notation. So there's an automated flattening ongoing, which translates it into a table structure or table schema. But you can also inspect the source schema, the nested one, and you can find out which of the target properties of the flat representation of the source schema is mapped or came from which real source property in the JSON schema. So you have the possibility to scroll here and you see what is the flattened name, what was the name of the original property, and the nesting is also preserved in this view. Okay, let us maybe cancel, since the schema is the right one. There are a couple of other settings that one can do. there are three things. First of all, consume other schema versions. That's a toggle that I can either activate or I can not activate. This means if a Kafka schema or Confluent schema has several versions, I can specify, okay, please try to consume also other schema versions, maybe older schema versions. And then the replication flow tries to read also messages that have older schema versions, but still of the same schema in use, based on a simple logic. If it somehow is compatible with a table, then it will consume the message. If that is not true, then it will either ignore the message or it will fail the replication task. This is the rules are more or less obvious based on schema versions can differ quite a lot, and a table schema cannot be changed arbitrarily. So there are certain rules, but there's going to be a block which explains this in more detail. It would take too much time now to explain when a certain schema version can be consumed and when it is going to fail. But what we can do is we can say, okay, let's try to also consume messages that use older schema versions or newer ones. And I can also specify simply to ignore schema mismatch. Means if during a replication task, there's a message that is consumed by Datasphere, it contains a schema, but the schema is not compatible with the schema that was used to create the target table, then it will simply ignore the message, throw it away, and will continue to replicate. So it will only watch the topic and consume the messages that comply with this specific schema that was configured during design time. There's also a fail on data truncation property, which is needed because certain properties in a JSON message, for example, a string in theory can be arbitrarily long, but in a HANA table, we have the envarchar property, which can only have 5,000 characters. So here we can specify whether a replication task shall fail if it reads a property in a Kafka message that is too large, so to say. The last important point that I want to mention here is the starting point. So what will happen if we start a replication where Confluent is a source? The initial load is immediately skipped. So there does not exist a concept of an initial load when we choose Confluent as a source, but it will directly switch into Delta mode because it does not really make sense to talk about an initial load in the context of a Confluent or Kafka topic. We simply can configure when the reading shall start. We have two options: either read from the earliest offset, that means as soon as the replication flow is deployed and starts running, it will consume. It will start consuming messages, and it will start with the earliest offset that it can find in one of the different partitions of the Kafka topic. Or we can simply state, okay, let's read from the latest offset. That means the replication flow is deployed, starts running, and as soon as it is ready to consume messages, it will only consume new messages that are written to the Kafka topic. So those are the two configuration options in the Confluent source settings. And yeah, that's more or less it. Let me maybe switch to the data builder again. Yeah, let me discard this. And let me show you the target table. In the meanwhile, it should have been replicated. Yeah, here we can see it. So it was created, and let me show you the preview. Here it is. As you can see, we have the different properties of the Confluent message. Here it is. What you might notice is here is a history that was an array that's not contained in this target table. The reason for this is that currently, with the first shipment of this feature, we do not support arrays because this is a little bit more complicated when it comes to flattening. We are already working on this, and it will will be shipped as an enhancement of this feature beginning of 2025. But the other properties have been replicated, or also the ID. And there is such an auto prefix message ID. So that's a synthetic key, so to say. And it is filled based on the partition where the message was retrieved from a Kafka topic, as well as the offset. That means, for example, for this the third line where the ID is 2, we had partition 2. So in the Kafka topic itself, the message was stored in partition 2, and it was the first message that was written into that topic partition. And the last line here shows, same partition, but offset 1. And then, the first 2 lines, they were stored in different partitions.
Hi, I'd like to show you the new improvement that we have around the task chain area, which is the ability of sharing and consuming task chains from one space to another. And by doing that, actually, we can then consume the chain as a child of another chain in any other space. And by doing that, we are in fact enabling the option of creating global task chains that are able to schedule and orchestrate multiple chains across the whole tenant. That offers a great benefit by having a better and more efficient orchestration in terms of data and as well better resource management on the entire tenant. In addition to that, with that feature, we are as well providing the option of importing and exporting the design of a chain in JSON format. So I would like to jump to the demo to show you that in action. So I'm going to go to the data builder and we'll quickly create a task chain in space demo1. And I can just drag and drop any object over here and immediately deploy. And let's call it shared from demo1. And now that I'm deploying it, we'll see now the new option will appear here. That would give us the option to share that task chain. It's possible to do it either here from the editor directly or as well from the data builder landing page. And here I can just type in the name of any chain, any space that I would like to share it to. So I'm now going to share it to demo 4. And now I have started sharing. And it did, in fact, finish already sharing. It is now shared to demo 4. To double check on that, let's move to demo 4. Here you can see that I immediately have it visible for me in my list of artifacts here. And now by going to the chain, if I try to create a new task chain here, then it becomes immediately available for me here to drag and drop and to consume in the chain that I'm creating here as a child. And you see here as well, by clicking on it, we have a new field that indicates the space of where it is being shared from. And in addition to that, what we can actually have is multi-level sharing and nesting as well. So that means that if the child of a chain can be shared, but that child as well could have a nested chain that is being shared from another space. Like here, what I have in the image, you can see that if we have here space demo 1, 2, and 3, and in demo 1 we have a chain that is consuming a shared task chain from demo 2, and as well the task chain in demo 2 is in fact as well consuming a nested chain as a child that comes from demo 3. And but to run that, I actually then would need during the runtime to have the data integration role in all three of them, so in demo 1, demo 2, and demo 3. Otherwise, it will fail in the point where I have no privilege to run. So I can show you that I had actually created a chain similar to what I had just shown you now in the image. I can go to demo 1, and if I look here at this task chain, and we can have a look together at the dependency graph. You can see that is how it looks like. Now we have the task chain that is here in demo 1, and that task chain has two children. One is a remote table, and the other one is the nested chain that is being shared from demo 2. And demo 2 as well has a dependency to another task chain that is being shared from this case demo 3. I could of course also navigate from here, but I'm gonna go to open the chain here, and I will as well start a run now. And of course, I can also navigate from here if I have the right privileges. That means if I have the data modeler on space demo 2, then I can also navigate from here directly and can have a look at the child chain and to be able to know how does it look like. And you see now I had in fact navigated. Now we are space demo 2, and that is our chain. It again as well has another chain from demo 3, but we do not need to navigate further. So one more thing, like I mentioned at the beginning, that we also provide now with that feature is the ability to export and import the task chain definition in JSON format. I would like just to highlight that it's important as well to know that if email notifications are configured and are enabled on that task chain, that when exporting it, we can actually export all the email configuration. However, for the mailing list on whom the email notifications are going to go, that information cannot be exported. So the information on the people who are to be notified cannot leave the Datasphere tenant. That is for data protection and data privacy. That kind of information cannot be exported together with the chain. However, information like when to be notified and what is the content of the email, that can be exported, but the data of the people who are getting notified, that cannot be part of the definition of the task chain. And so now here, by clicking on that button on the top of the page, we are able to export the task chain. And now I just clicked on it, and we have now exported it. We can have a look at it. We see now that we have two children on that chain, one remote table and one task chain. And in fact, like mentioned, we have as well email notification active here, condition on when to be notified, and the notification content as well. What I can do right now is I can change the name of the task chain, because we are not allowed to have duplicate chains, and I can now go back and import that task chain, given that now I'm importing it with a different name. So that should work. You see here it already offers me to import it with the new name I had added, and it now gets imported. And that is basically just a copy of the other chain. It's a duplicate just with another name. Yep, that is the one that we just imported right now. I can as well now navigate to the data integration monitor just quickly to show you the chain that we had triggered moments ago. Yep, it did actually in fact finish already. So the chain had completed with all the children of it, and you can see here that we are able to look at the logs, and of course if I am also authorized to look at the logs of demo2, then I can as well, I would be able to navigate from here directly to look at the logs of demo2. That means I need the data integration privileges here, and here as well I have the option to, now that I'm in demo2, I could navigate back to the space demo1, which is the parent task chain by here, or if I still have the privileges, I could go further to also demo 3. But I'm gonna navigate back to demo 1, and yeah. So I think that would conclude my demo, and thank you very much for your attention.
Thank you, colleagues, and over to the modeling area with Brendon and Florian.
This story focuses on the data type validation that is now available in views. Here you can see that I have a view open and I've already run my data validation, and it's validating a number of things that you can see here: my keys, data types, and hierarchies. And I'll just give a little bit of a demo of how this works by breaking my view. So let me go in and just make a small change, let's say to the type. So here I have something that's a car, and I could change it into an int. And as soon as I do that, I will get a warning up here that it is not happy. I'll also get a warning here. And if I deploy this view, which it will give me a warning, but I can still deploy it. And now that my view is deployed, I can open my data validation and revalidate. Now it's going to run all of my validation checks again, and it's going to tell me that the types are inconsistent because we just changed them. So I could change that back. I'd have to redeploy again, that this validation only runs on the deployed view, and fix that. And I could also do similar changes right in the hierarchies if I messed up the hierarchy or had an issue with circular hierarchies, and my data validation would showcase what the issue is and help me diagnose that much more quickly. This is a demo of the new view persistency guidance that's available. Here I have a view open, and it does have performance errors. It in fact doesn't actually display the data preview. If I try to do that, it will think for a while and then give me an error. If we look at the lineage, we might have some guesses that we're going to have problems with this view because there's many layers of underlying views. But now through the data integration monitor, we can get guidance on which of these views to address most directly to improve our performance. So I'm going to switch over to the data integration monitor. I'm already in here in our space. I'll open up our view. And when I open the view, now I have the option to start the view analyzer up here. And I can run this without the additional options for now, just to reduce memory consumption. And this should run very quickly. It'll start the task. And once that runs, I can switch over to the entities and refresh. And now I can see the list of all of my views that are under this view and the data persistency candidate score. So this is totally new, and it shows me the best option and then some alternatives, some good options, and some that are not applicable to do this. So just based on this, there will always be one best option. I can expand this. I can see the reasons that it gives me to persist this, like the 25 targets and 2 sources. If I open the monitor, that will then bring me in the data integration monitor to this additional view. And I could still dig into this more, or I could just start data persistency. And once I start the data persistency, then that will run in the background. And then having this table persisted should fix our issue with the data preview. I can also just tell you that was this view right here in the lineage that we just persisted. Just looking at the graph, Seems like that's pretty obviously one that would be nice to persist. This view up here is our second best candidate according to the data integration monitor. And now it should be returning the previewed data. So really nice ability to look into the underlying views and get guidance on how to improve performance by persisting the right objects. There's the new explain plan integration with the view builder. So here I have a view, and now if I scroll through the model properties down to data persistence, I can open the data integration monitor and look more into this view. And so this is a follow-up to the previous story where we already talked about the persistency guidance. Now we'll be going into the view analyzer, so I can start this. And I can now generate the explain plan. So now I'm going to check this box this time, run it again, and this should run, and I can look in the task log that it's running. It's now completed, so I can refresh the page. And now I can see the explain plan file here. So I could download that, or I can view the details directly. When I view the details, now I can see exactly how HANA plans to execute this view. And this can be very helpful for understanding performance, particularly for more complex views. Enhancement enables us to use the data persistency with views that include one input parameter. So here we have a simple view called view with one parameter. I will open the data integration monitor here. And now we can run our view analyzer and generate the explain plan. So we'll do that. We'll need to refresh to see the results. And we see our view with one parameter. When we look at it, we see that it does have one parameter and it does have a default value. So now we are able to start the data persistency, which was not previously available. And when that runs, we will then need to generate the explain plan again to understand how the view will perform once it has the persisted data. So let's run the view analyzer again and then refresh the results. Go to the entities. And now we see that this data access is partially persisted. So we see it here. And we see over here our one default value again. So that's really nice to be able to improve the performance of views that have input parameter with the default value. There is a restriction. If we do not have a default value or we have multiple parameters, this will not work. So I'm going to switch over to a view with no default. And here we can see that if we look at this view, it's going to give us an error. It's going to say view cannot be persisted because it has more than one parameter. So that is required, but still a very nice enhancement in terms of improving the performance with data persistency for the views that do match the requirements of having a single parameter with a default value.
I have some news regarding the data marketplace, and we recently introduced the lineage and impact views from the provider side of the house. So we are now exposing the lineage up from for the providers to make sure that you can understand exactly which views are used in your data products, and on the other hand side, how your data products are used in further development. Important to know, this not only works within one tenant, but if you have paired your tenants within one catalog, this works there as well. And we did that basically to make sure that you, especially in an internal data marketplace scenario, you are able to understand how and by whom your data products are used. This is especially important when we are talking about transporting data products. Having a life cycle on top of that. And with this new innovation, this becomes now more handy. When we quickly jump into the system, you can see here that I created a sample data product. And for those of you who haven't seen it yet, this is the new representation of our data products in the catalog. You can see from here that this data product consists of one view, in our case, the sales view, with the columns here. And if I go now to this sales view in the catalog, I have, of course, many more details here on what this view is about, but I can now open the impact and lineage analysis. And this will now show me not only the items or the objects that that have been used to build that very view, but you can see now that this view is also used in this data product here by this data provider. So you can see the sales view in here, and you can see that also the installations of that data product. In our case, or in my example, I installed that product in another space within the same tenant. And here you can see that I even put another view on top of that. So with that, you have now the whole overview in one glance. And that's already it from my side. Back to you, KP.
Thank you, Florian. And let's have a look at the administration governance area, where we also introduced a very interesting new feature, which is the logical space deletion. So basically, up until this release 2024-21, if you deleted a space, all the artifacts within that space, the connections, the models, everything was also completely deleted and removed from your tenant. What we introduced now is a recycle bin, basically. So if you delete a space now, it will be first moved into a recycle bin. And if you want to permanently delete all the content in there, then of course you can still do that out of the recycle bin. If you accidentally deleted a space, then you can rebuild it basically and restore it back from the recycle bin. So let me show you how that works in the system. So if you're in the space management of a tenant and you have a tenant you want to delete, I simply mark it, hit the delete button. Everything looks like it has been before. So you confirm by typing delete in capital letters, press the delete button. And what happens then is you see on the left-hand side, there is already a side panel there. The number of spaces got removed from 100 to 99, and we have in the recycle bin one additional space now. So that space is the to be restored space. So there are others which have been deleted in here, but let's restore this one. Hit the restore button. And it's removed from the recycle bin. We have 100 active spaces again. And if we look it up from here, it's actually there again. So simple as that, but very useful feature, especially to prevent accidental deletions on the spaces level. This next new feature is a small but impactful one. It enables the multi-availability zones in Datasphere specifically for the SAP HANA Cloud runtime underneath via a support ticket. So it works via SAP Node 3518414 as linked here on the slide. So it's basically if you follow that support node ticket and then open up a ticket, we can enable that multi-availability zones for you, which then gives you additional resiliency against infrastructure failures on the hyperscalers compared to the current single availability zone versus multi-availability zones. So it can automatically then switch over to other availability zones within the region of your data center. It enables an asynchronous replica of the customer HANA runtime and allows that feature for you to give you more resiliency. With that, over to Amok for another new topic on the system monitoring side.
With Wave 2024-24, we have now introduced presets and filters bar on the logs tab in System Monitor. Before the release of this feature, it was possible to use the advanced filtering in the system monitoring to filter rows on the basis of inclusion and exclusion configuration. Now, it would also be possible to select predefined filters in an attempt to quickly filter the view in the statements and the tasks tab. This is a way to complement the advanced filtering and not to replace the advanced filtering. Let's look at that in the system. I'm at the home page of SAP Datasphere. Now I will navigate to System Monitor and then onto the task logs. Once the task logs open, you would realize now that we have a new bar at the top that is letting me select some presets. If I select one of them, I would be asked whether I want to filter it. I want to specify some date time ranges, or I want to select some custom options based on last 1 hour, 6 hours, or 24 hours. Additionally, I can select one or more spaces from the list of spaces in my tenant. And similarly, I can also select if I want to filter on the basis of statuses. These filters are quick filters, meaning that they're going to complement the existing advanced filtering which was accessible through this gear icon or the settings icon. We're now going to apply a few filters. And now the records are filtered by the quick filters that I've maintained here. And you would also see that the filter query has been accordingly updated. It shows me what is the filter query that is being applied. Now, at this point, if I feel that the filter that is applied is not good enough, I want to change it, but it goes beyond the quick filters that are maintained here, I can select the advanced filtering and apply an additional filter, or also get rid of some of these here. For example, if I now want to get rid of the statuses, I can do so and click OK. The filter query is accordingly updated, but what can also be noticed here is that the quick filters have been resetted to not select anything. This is because the filter query is always carry forwarded from the quick filter to the advanced filter, but not from the advanced filter to the quick filter. This is the default behavior of filters in System Monitor. If I now move to statement logs, you'd see here that this page also now selects or supports it supports quick filters, but only for date and time range. This has been done keeping in mind the kind of records that are there existing in both these tabs. So here I can still select the same kind of date and time filters that are possible in the other page. Similarly, the advanced filtering behavior would be same in both the task logs and the system logs. As mentioned, this is a way to complement the filter behavior to make sure that the most can be achieved by selecting filters from both the quick filters and the advanced filter based on the requirement.
Thank you, Amok. Coming now to the last section of the session, we take a look at the planned features for Q1, Q2, and later next year. We have a packed Q1 already, so there are in all different areas of the solution, we plan new functions, features, and also enhancements, of course, of existing functionality. Looking at the data integration side, we plan on introducing new sources and targets, like with Microsoft SQL as a source and SAP Signavio as a target solution in replication flows, and also plan on enhancing the replication flows with an export and import capability. So basically the design time artifact in season and the JSON format, like you know it from other modeling artifacts, will then be also available via the export and import button there. On the semantic onboarding side, we plan on introducing additional capabilities for SAP HANA Cloud calculation views to be able to import them and directly create artifacts in Datasphere out of them. On the authentication side, also we're planning for ABAP-based systems, but also others like Amazon Redshift and Microsoft Azure to support non-basic authentication, also a great step forward. And on the Confluent side, you heard Daniel Krämer earlier in the session talk about that arrays are today not supported, but we plan on supporting them in Q1. So very shortly after the initial release of that, we will also be able to support arrays then and eliminate that deficiency. Looking at the task chains, we plan on introducing the support for failed tasks, specifically within nested task chains, and being able to re-trigger them. So that's what we usually also talk about, a deep retry, because it's not a task within the same task chain, but could be a task within another task chain triggered from another task chain. And so that's a little bit more complex activity. But that's what we plan on delivering in Q1, as well as the support for the REST API as a task in task chains with synchronous and asynchronous modes. And in addition, looking at the marketplace functionality, we plan on introducing license-specific data selections, which is then also supported via the CLI on the marketplace, but basically enables you to create one data product and different data selections based on the license type of that data product. If, for example, you have a demo or sample set which is only provided for certain users and the full data set for other licenses, then you can enable that. On the monitoring side, we will integrate then with the Cloud ALM solution of SAP to enable health monitoring as well as task execution KPIs as a first step in Q1. Very interesting. Looking at the modeling side, we also have one major topic here with stacking of analytic models, basically being able to reuse an analytic model and build another analytic model on top of it. Also, this includes sharing between spaces, meaning an analytic model from another space can be then used as a basis model and building another analytic model on top or additional models. We've also introducing central measure definition here for analytic models. We also plan on introducing secondary structure capability into the analytic model, and people might know that from BW, which will then also come now into Datasphere functionality. And in addition to that, since measure definitions can become quite complex, we want to introduce a new dependency graph to be able to visualize the measures, how they are composed, etc. On the OData API, we plan on enhancing that to be able to expose additional semantics, which are currently not supported via the interface. And on the model validation framework, which was introduced in 2024, we're trying to enhance the different checks and add checks there on multi-language models, also on association consistency, as well as to be able to identify unassigned nodes and hierarchies. Looking at the catalog side of the solution, there are also multiple enhancements planned, like for example the mass import of glossaries, terms, KPIs, etc., which sometimes are stored already in flat files, Excel or CSV files. So information is available in written format, and the capability to import that will then be added. So it's basically easier reuse of existing information. We will also enable the catalog for discovery of data products from SAP applications. That's a topic we plan for Q1, where we also want to introduce data products directly managed from SAP applications and to have those now also integrated into the catalog specifically for discovery and of course for also use with Datasphere. that will be enabled then. And AI assisted search as well as generated catalog assets is also an interesting one, because you don't want to type always all the descriptions. This will give you then a generated catalog entry. You can of course adjust it and enhance it whatever you like, and or directly adopt it in order to boost your efficiency in generating catalog assets. Looking further than Q1, of course, in Q1 and Q2, Q3, etc., we plan on expanding our data center coverage like we did it in the past over the different quarters, specifically focusing on Google as well as Microsoft Azure hyperscaler regions. Looking at Q2 specifically, there's a bunch of topics which I took here, like for example the addition of a custom home screen card where you can have your own text, hyperlinks, descriptions, etc., which might link to your internal documentation or other assets you might find useful for people using Datasphere. On the replication flow side, two interesting plans here. On the one hand side, adding source data sets which can be used in multiple replication flows then, and as well supporting views as a source in replication flows. Also great new functionality we plan there, as well as the local table delta read API, so that you can read local table or the delta information from local tables there via the API. Looking at the modeling side, versioning is a big part. We currently support to go one version back, and this is then a more comprehensive versioning concept where you could go back to different versions in the past in case your requirements need that, or there are certain inconsistencies where you need to revert to earlier versions. Very helpful. And on the scheduling side, right, also local time zones, also specifically with respect to daylight saving time changes, etc., will be introduced. Catalog as well will have in Q3 some major updates with additional capabilities crawling S/4HANA as well as HANA Cloud, and then later in the year also SAP ECC is planned as a additional crawling capability. On the modeling side, restricted measures in analytic models that really restrict also on hierarchy nodes, which is currently not supported, but we plan on supporting that. And the support of the new Delta only mode in replication flows is planned for Q3. And then looking further ahead, few things where we add additional sources, like with Google BigQuery, which is there today as a target only. Self-service for the multiple availability zones, REST API for like connectivities to SAP Ariba, and we plan on introducing namespaces and also being able to share the dependent entities in modeling. So with that, we come to the end of today's session. So thanks to all the speakers for providing the great content. The material will be made available on the website. And thank you for being with us today. And have a great start in the new year. And I hope you enjoyed it, and come around next time when we have our next What's New session next quarter. Thanks and bye-bye.